And we are live with our 34th episode of Absolute AppSec. I know you're laughing. I'm Ken Johnson at CK Tricky on Twitter, and I'm joined by my co-host Seth Law at Seth Law on Twitter. Seth, say hi.
Hey everybody, welcome back. I know it's been a couple of weeks since we've been here. We'll get into that here later tonight, but yeah, welcome back to the show, I guess. I'm going to sing our intro here. No, never mind. That's no good.
Still don't have an intro. Probably we never will have an intro. We'll see. We'll see if that changes. We did have a guest scheduled for this evening, but she, due to work plans or thing from work that popped up, which happens, she wasn't able to make it. So it's just going to be Seth and I tonight, kind of winging it. Honestly, we've been, like Seth mentioned, we've been out for a couple weeks, and we'll talk a bit about AppSec USA and AppSec Day Melbourne. I learned it's Melbourne. That's how you're supposed to say it, which I thought was really weird. It's like not Melbourne, Australia. It's Melbourne. Anyways, along with that fun factoid, you'll learn more stuff tonight. So, but yeah, Seth, I think you wanted to start with a...
I'll take over and do kind of an AppSec minute. One of the talks that I've been given for the last year has been about security unit testing. And this has been on my mind for a while. As I went through my college days, I actually did quite a bit of work on unit testing, like from a quality assurance perspective and identifying edge cases. Like I remember taking a couple of classes that's all that it was about. And as I got into the security industry, and application security specifically, I've always wondered why we don't, like my favorite punchline is that security testers are just really bad QA testers, because the level of effort that we put into security testing is very different from what a QA tester would do, right? Even from just like a plan perspective, how they put together their payloads and everything along those lines. So as part of our AppSec Minute tonight, I wanted to talk a little bit about crafting security payloads for your security tests. So rather than approaching it from an exploit perspective, when you are trying to integrate into a CI/CD pipeline, I recommend more of a case-by-case approach on finding flaws rather than exploits. So if we take FuzzDB, for instance, you look at the XSS attack payloads, and we'll post a link to this. Let's see, I'm pulling them up right now. If we look at the XSS attack payloads, there's hundreds of payloads that are in there, right? Just the other list has something like 167 different payloads, which are really interesting from an exploitation perspective, but don't necessarily give us a lot of information outside of maybe running 5 or 6 of those payloads from a flaw perspective. If you're searching for cross-site scripting and encoding flaws, there are realistically a limited subset of characters that we need to search for. We don't need to search and know completely that this one instance of XSS was vulnerable in IE9, for instance. We just need to know that the flaw happened and that those characters were unencoded. So my recommendation for security testers when they're trying to implement those tests in a CI/CD pipeline is to identify those dangerous characters. So one, like the XSS other payload list from FuzzDB, realistically, you're probably looking at only 5 or 6 characters that you really need to search for to speed up that test and positively identify cross-site scripting, or at very least the possibility of cross-site scripting. Things like a less than character, a greater than character, a single quote, a double quote, and maybe an ampersand. And then realistically, you've actually covered all of the different payloads that exist in that could be dangerous to your application. Ken, have you ever implemented any sort of security unit test in that way?
My unit test, creating security unit tests, as you know, have been primarily for educational reasons. Hold on one sec. My son just dropped in. Hey.
I was
Hey, Max.
Oh, you're upset?
Yeah, why?
Oh, come here. Sean. Yeah. Okay. So I'm gonna do this podcast now. So
It's good. It's quick.
yeah. All right, I'll
So-
talk. Go talk to mommy for Halloween.
No, stop.
What do you mean?
I'm not gonna help.
Okay.
I was like so
See,
sad.
this is what happens when you work from home and you do podcasts from home.
Well, so
You can continue without me, Seth. Off.
No.
All right. Give me 1 second. I'll be right back.
No worries. It looks like we've got Stefan Edwards joining us tonight as well.
You have children.
You can continue without me, Seth.
Yes, yeah. Ken has children, so I have children. I have locked doors too, and like we've got Stefan Edwards joining us tonight as well.
You have children.
Oh, Stefan, you probably do want to mute the YouTube channel. I have children. I have locked doors too, and like we've got Stefan Edwards joining us tonight as well. Oh, Stefan, you probably do want to mute the YouTube channel.
That's what I'm looking for right now.
Tonight is all sorts of lively. Like this is
Yeah, it is. This is live, like you would not believe. Apparently.
yeah. We've said it before. It's not super. I mean, even now I got my son on the other side of this monitor. He's just messing with my bobbleheads. So, and Stefan, it looks like Stefan joined us. Stefan was asking about, or Stefan was mentioning something when you were talking about fuzzing.
Yep.
And so I thought he could add to that conversation.
Well, I mean, obviously I work in a slightly different space, but, property checkers, hypothesis, those sorts of things. I mean, they're very interesting to see what people are doing with those. And I was just curious what your thoughts are on, those sorts of that sort of fuzzing, like tactical guided fuzzing, as well as things like AFL, Redomsa, those sorts of things.
Yeah. I'm all for it. Like I said, most of my thoughts around this were formed when I initially doing some of the edge case testing and other things that I did, all the way back in my college days, right? The plans that we would form and everything like that, it's very, very targeted. And I still feel like we do a pretty piss poor job of that when we're doing something like a web assessment. We really don't search for a lot of those edge cases that are interesting and that actually could lead to further exploits. But you're jumping more into almost the low level. You have access to code and you're doing the testing from a plan perspective. Is that what you're asking about?
Well, I mean, you can certainly, right? Like we have symbolic executors that actually work on binary, right? Like, so in case everyone doesn't know, I actually work for Trail of Bits. So we have tools like Manticore, which actually work at binary level. They don't necessarily have to have source code access. They work on x86 binaries, EBM, and that sort of stuff. And then we do have tooling to lift binaries up into a higher representation and do that sort of testing against them. This was what I was going to talk about next time I was on the podcast, but we're already getting into it slightly now.
Yeah.
But those sorts of random mutation checks, and like you would see in Redomsa or in AFL. AFL obviously needs source code access, or it works best with source code access. But those sorts of unguided fuzzers are pretty interesting for finding edge cases. I actually was just fuzzing a client's virtual machine. So a client gave us a bespoke virtual machine with a different instruction set, and we wanted to see all of the edge cases within that virtual machine, opcode wise, as well as the formatting and structure wise. And I threw Redomsa at it. One of my coworkers, Bobby Tonic, he threw GoFuzz at it.
Yep.
So we got it from both the random side as random binary mutation and generation, all the way through to guided fuzzing and whatnot.
Yeah.
Super interesting.
Yeah, and it's interesting how how you guys come at it, right? From most of the time that I'm talking to developers, it's not necessarily from the red team side as much, right? It's not like they're throwing me a binary or something like that. They're throwing me almost higher level code, right? Something that's running on that virtual machine. And at that point, it's pretty easy for us, the code review stuff that Ken and I have done. It's easy for us to step into. All right, we know that these are all the parameters. We know this is everything that the application is accepting, so we can write those unit tests out. very rarely do I actually see them go through that effort, though. So then turning it over to somebody like you, where they've handed you a binary, and to be fair, I don't know like how Veracode or somebody else approaches that same problem, right? Where when they get that binary from static analysis perspective, if they're running it through those same sort of fuzz tests, or if they're approaching it more from the exploit, hey, we know that this string causes a SQL injection or whatever, or some sort of buffer overflow. So those are the payloads we're going to use, rather than something like the Redomsa, where it is just we're mutating things to see what's going to happen.
Wait, I didn't realize Veracode does fuzz testing. I didn't even know that.
I mean, I think from a C++ perspective, the security tests that they're running have to be some sort of a fuzz, right? It's probably not, but it's probably payload based. I mean, it'd be interesting to talk to somebody that's there to actually see what they're doing.
Yeah. There's a couple different paths you could take with that. You obviously can do mutation testing, right? Like you can mutate known, like what you did with Sputter, Seth. Take known payloads and just mutate over that small set of things. Like you notice the 6 characters that you really had to worry about for XSS and SQL injection and that sort of stuff. You can work from there. You can work random walks. So you can literally take something and just start to generate garbage and see where it gets you in the binary. And you can do guided testing. You can do all sorts of interesting directions. Depends on really what you want to do. We cover like fairly bit, especially in the blockchain space. We have Echidna, which is like quick check. It's property-based fuzzing, right? So you describe some property some invariant about your application. Some number should always be greater than 1,000 or something like this. And Echidna will walk through and call all of your functions within your program and see if any sequence of functions actually causes your program to break that property. So giving it random data, random function calls, can we break the application?
Okay.
Whereas like symbolic execution, you're actually pushing a symbol instead of a concrete value and walking through and seeing what the application does. So for example, if you come to an if statement, you can generate both sides of the if statement and then see which conditions actually provide you both sides there, what path you get to. And then you throw that into an SMT, a satisfiability modulo theory, a theorem prover basically, and you ask it, what value concretely gives me this condition? And how do I get to this error path down here? So we've done a lot of research, and other companies, other teams have worked on those sorts of things before previously. And there's a lot of really interesting stuff you can do in the space. That's why I was curious what you're seeing there and whatnot, because obviously we work in a slightly different space.
Yeah. And like I'm saying, like the low level, the point that you're getting to with most of those apps, most of the developers that I end up dealing with aren't necessarily even approaching it from that perspective. They're doing more of a QA, functional UI test, and then we're like modifying it so they can actually approach the compliance of, hey, we've actually done some security testing. So almost re-implementing a black box approach into a level that can go quickly and at least give them some assurance that they haven't messed something up, right?
Completely, yeah.
Yeah.
I mean, like one big way I've seen this done is like with authorization tests, making sure that there are negative test cases, and just validating that the authorization works as expected. I mean, I would consider that as a security unit test. And then maybe it's not so much fuzzing, right? But it is asking questions and validating that things are working as they should. Yeah, and then the other way in terms of fuzzing is we actually do have someone we've got like a modified version of GoFuzz or whatever. Is that what it's called? GoFuzz?
GoFuzz is one of the Go fuzzing libraries, yeah.
Yeah,
which is great.
Right.
It's really awesome.
So this is right. Yeah, so then it's like I believe so you can basically hook this into like a C++ app and yeah, it just has like a ton of payloads that it can run and fuzz. And that's the only other, I guess, from my like practical experience, or yeah, what I've seen put into practice, it's all been pretty basic, like not about, symbolic execution or anything.
Well, the way I explained it, I had a client ask this very question the other day. Like, can I get rid of my unit tests if I'm fuzzing my application? Like, do I need to have these sorts of things anymore? And the way I explained it is like, when you have unit tests, when you have those sorts of things, you're codifying what you intend to happen, negative or positive, right? Yep. If you have a failed test, you're expecting it to fail for a specific reason, an authentication error or something like this.
Right.
Whereas fuzzing, you're trying to find all of those things that you did not consider, that any of those intentional items that you could not codify. You're looking for fuzzing to find those sorts of things. And then symbolic execution is one step above that. And beyond that is abstract interpretation, whereas you're really starting to model the way that the application works and really codify all those states and those paths and those transitions between them. That's when you're getting towards the higher levels. I guess fuzzing is one way to get there.
I guess my question to you is, do you see that? Because like I'm wondering, I know we do fuzzing, especially with a variant of GoFuzz on like driver libraries, right? For say connecting to a database or something. But in terms of some of the more popular languages like Node or whatever, Ruby. Okay, well I won't say Ruby, but Elixir, Node, etc. Golang. Maybe not so much Golang, but are you working or are you seeing people fuzz like the frameworks and the languages themselves to see if they're like their web middleware is vulnerable to something, or like I just don't. I'm trying to besides the libraries put a concrete sort of like idea on how that would, like, what's the value, I guess, of that.
Sure. I mean, we tend to bring it in when it's something very complicated that we can't ourselves model very quickly and understand. So similar to what Seth was doing with Sputter, right? It's like we're trying to find all of the places that your application breaks that I can't think of some sequence of ampersands and angle brackets to get there. But now you're just doing it at a slightly lower level. I used it quite a bit when I was out in Salt Lake City for a specific client that Seth knows. And it was just like, there was no way that I was going to be able to figure out all of the edge cases of this application. So creating a payload, seeing what crashes, and then saving that, and then walking it back and maybe expanding or minimizing the payload myself by hand, really, that's where fuzzing really helps me. It helps me find all of the weird things that I myself can't think of. And symbolic execution is very similar as well. It finds all the weird paths through an application that you maybe literally could never create within a normal system.
Have you seen any like framework level issues doing that? Like a framework's just whatever, it's built on top of its libraries that it's built. Like it can't handle certain things. Maybe you've presented denial of service conditions or anything like that.
Yeah, denial of service. We found injection issues, lots of crashes, lots of parsing issues, those sorts of things. Absolutely. We've seen those sorts of things quite a bit. You
don't want to name any frameworks?
No, I can't name any.
Damn it.
Lots of C code, lots of Go code. We've actually broken conditions within Go itself. Now they've been fixed in later builds of Go, and we don't hit those same edge cases as we're going through, but it still stands like we're hitting something weird in older versions of Go that you just was not meant to be hit.
That's surprising. I did not expect Go to pop up as.
Yeah, I would think anything with that level of scrutiny is going to have failing edge cases, right? There's just so much code in some of those. I mean, you think about something like Node and the number of APIs, and then especially as you introduce middleware into it, Express or whatever else can, the attack surface that we tend to look at is very kind of, hey, you implemented something on top of that, right? Rather than, hey, you're kind of asking about that middleware or the framework layer. And building a fuzzer for that is almost like you've got to model out an application that exercises every single API call, every function call, every possible object creation. So there's not a lot of, I don't think there's a lot of people that actually go through that level of effort.
Yeah, because I mean, you've got your request and response sequences, which are being handled by like the middleware, and you mentioned Express being one of them. You've got your ORMs handling SQL calls, and Stefan mentioned, finding some injection issues, which I think is total. I mean, that makes total sense, honestly. And that's something that I think would be, I almost want to say, would be pretty quick to find. It would be pretty quick to find injection issues that way, fuzzing.
Mm-hmm.
Like, what else do frameworks handle sessions? So they do like serialization of sessions. I was trying to think of what else, like
input validation issues, output encoding issues, memory handling issues, memory allocation issues, memory pressure. So for example, with fuzzing previously, I've actually been able to force conditions such that the application actually crashes because it just allocates too much and then it EOMs.
Yeah, that makes sense. What about like size of the request? It just, I mean, we've got web standards that put caps on those things, but like if it's not, was that part of the parsing issue that you were talking about too? Like,
it can be, absolutely. But then also when you get to fuzzing, it may be something like you send it a request that's 10,000 characters, but you tell it it's like minus 100,000 characters, and the application does something really wonky with that combination there. This was actually generated by fuzzing. So
interesting.
Yeah, there's a lot of interesting stuff that falls out with it. And then for developers, you have frameworks like, like Hypothesis and like Echidna and those sorts of things, depending on the space that you're working in, to allow you to do property checks, which is basically fuzzing with specific unit test style declarations involved. So there's a lot of interesting stuff that's coming out, especially recently, that's been very good. I can post a link to a Hypothesis for you.
So are we going to see some CVs pop out with your name anytime soon?
No. Because everything I do is under non-disclosure. But I mean, some of the other folks that have worked at Trilobits and do work at Trilobits are really great in that space. So like Ryan Stortz with Zombies on Twitter, and Sophia, I'm going to mangle her name, but Sophia Kalikendi on 44 on Twitter. Sophia actually just won Flareon with some of her tooling. It's a reverse engineering challenge.
Yeah, I'm looking that up.
So there's lots of tooling and lots of things that come out in that space that we do just from fuzzing, or starting with fuzzing and then walking it back the entire way, or starting with symbolic execution and walking back to a payload we can test.
I think the concept of being able to ask questions, like you said, sort of backwards, in the sense of how do I get to this conditional, or sorry, not this conditional, but the code that executes in the case of a conditional, and go backwards from there. That's pretty interesting. But what are like I mean, is it sort of a situation where you're fuzzing, you get a result that's unexpected, and then you walk back, or are you walking back? Like what's kind of the practical application of having that, of doing that? And also, I'm going to post Flare reverse engineering right now.
Yeah, we can pull Hypothesis as well. I can send that to you. But yeah, when you're doing symbolic execution, basically you're trying to find all of the various paths, and then you would request some other proving system to tell you what the combination of these paths give you, the combination of values that actually got you to this location. So, for example, I'm working on a symbolic execution engine for the virtual machine that I've been working on, and so what I would do is, if you have like two numbers that are added, you'll add a trace. You'll actually watch that value throughout the rest of the application and build up this path of values. So it starts with 3 plus 4, and then over here we multiply it by 7, and then we, divide it by 12 over here, and for some reason that path that we walk through causes an error. And tracing all of those values and tracing that symbolically, we can come back to a concrete value, basically solve for x. So we start with, we don't know what x is equal to up here, and we trace through, and it's like, oh, x is equal to 3.79 for some reason. But we didn't code for that. It's not something that we came up with. It's just an edge case in our application for some reason. So.
Oh, and we should probably mention who you are. It's like,
no,
we never did that. I just thought about that. Like,
okay, oh, here's Stefan. Jump on in.
Stefan's actually going to come on to talk more about. I mean, we could talk a little bit about Stefan now, but both Seth and I work with Stefan. He's at Logical LOJIKIL on Twitter. I'll put it into the chat, both chats. But yeah, so I've said this before about you, Stefan, but you're basically the guy that I have to Google everything that you say.
It's funny, going to Trail of Bits, I can finally be the stupid person in the room. I can be the lukewarm, mouth breathing person who doesn't know what's going on all the time. And it's pretty phenomenal.
Yeah, no, that's me with every conversation that you and I have. So yeah, no, yeah. But all jokes aside, you've spent a lot of time at the low level sort of, obviously your background is in application security, but it's also in languages in general. Stefan's written a few of his own languages just for fun, which is that statement in and of itself. But yeah, so you've done a lot at the low level compiler sort of level, and you've done quite a bit with just programming language theory. I'm trying to think if there's. I mean, we'll talk more about your background, I think, when we officially have a Stefan devoted episode. But yeah, Seth, anything you wanted to add there?
No, not necessarily. I mean, our AppSec minute turned into our AppSec 30 minutes. I don't know. Whatever.
There's no agenda.
But in general, I when it comes back to it, what I was really saying was you want to do unit testing, but you want to be careful about, I like the targeted unit testing in a CI/CD environment, right? Even the testing that you're talking about, the fuzz testing that you're doing, can be useful, but I don't necessarily see that as something that you could run, within a limited time frame that a lot of these groups actually spin out, right? That's more of a concerted security effort to implement and find additional flaws in an application, whether they be security flaws or just memory handling that could lead to something, or just stability flaws, right?
Yeah, the only thing that's good about fuzzing is that if you take what you find randomly and then turn it into unit tests to make sure you never have that regression again.
Yep.
So it's it's outside your CI/CD pipeline, but it leads back into your CI/CD pipeline so that you have that sort of mixed feedback there continuously.
And that's a good recommendation in and of itself, right? You get a penetration test done or something like that. Anything that is found in that can easily feed into a unit test that would check to make sure that it never happens again, right?
Yeah, absolutely. I mean, that's what we recommend for, in the blockchain space, there's Truffle, which is used for testing. And Echidna does property testing, and things that you find from Echidna, which is, you can rewrite as tests within your Truffle space so that from now on that you never fail that test again. You never have that issue. Mm-hmm. And then you can rerun Echidna to, fuzz the heck out of your properties and see if there's some way that we break it now with new code releases.
Yeah, I found the link to Echidna, by the way, and put it in chat. Yeah,
it's a really cool tool. It's written by one of my coworkers, JP. We have a JP at Trail of Bits as well, not just JP at Invisium. So, but yeah, JP at Trail of Bits, super smart guy. Japesonator on Twitter, and yeah, he came up with Echidna. It's written in Haskell, so of course I love it. And it's really interesting to see the stuff that he comes up with that and all the different work that they're doing there. So
I like the diagram, the image for it.
Yeah,
What
you know,
is this?
it's a hedgehog. But Seth, to your point, like to have those tests that run within a specific time frame, the way we framed it previously is that like tests and static analysis should run like within an hour, right?
Yeah.
Echidna and property checks like hypothesis should run in like a day, and symbolic execution you should maybe looking at a week to get running on a very large application, right? And then when you go beyond that, when you go to formal verification, abstract interpretation, those sorts of things, you're looking at weeks maximum, weeks, maybe months of effort there.
Yeah.
So
Yeah, and that's kind of a good probably rule of thumb for any of that. Right? As you get into some of that higher level, lower level, whichever level testing, right? Besides just the normal security or like just the normal unit testing that you're doing, you're actually stepping into more framework issues that you may not necessarily see with your code that you've written on top of the framework. So it may still be a problem and it may still introduce a security issue, but it's probably has more to do with the overall ecosystem, and you're starting to discover more things than just what you've written.
yeah, exactly.
So it's not that it's not useful. Obviously it's an issue, and we see the same thing. Can you dig into some of those, and we find stuff with middleware or whatever in Rails or Node.
Oh yeah, there's always something.
Yeah, and whether it's based on a CVE or it's old version or it's something that's new, it's part of the ecosystem. It's definitely in scope, but it may not necessarily be a direct result of your developer's code on there.
No, right. So that's the reason I was asking that question is that so like normally when you do an assessment, you're not. I mean, if you get like some weird behavior back from your, like from your, I don't know, we'll say you're using Burp Suite or something and you're sending some fuzzing payloads at it and you get some weird behavior and okay, maybe you'll investigate a bit, but normally like framework level issues or whatever, like they that isn't something that you're really testing for, right? So it's interesting because I feel like if you put a decent amount of time towards it, and you see this with like, because you mentioned Rails, they have a I think they're on BugCrowd, maybe BugCrowd or HackerOne, one of the two. Anyways, they've got a bug bounty running because there's definitely things found for the framework. So that having been said, I'm curious like what percentage of paid research is occurring for like devoted to fuzzing frameworks themselves rather than just like the normal consulting model where you're being paid to just assess the code written on top of the frameworks. I don't genuinely have an answer for that. I have not seen a whole lot of consultancies in my experience doing framework level kind of research.
Yeah, I think it's hard too because most of the framework level stuff that you get paid for goes under NDA and you never see it again. It's one of the things that I was very interested in when I first joined Trail of Bits. I asked Dan about it, we talked about it, and we do a lot of open source stuff, but it's rare to have those sorts of resources devoted for you. And Cure 53 does some stuff in that space, and we obviously do some stuff in that space, but it's hard. It's hard to just be able to dedicate that sort of time and effort to a framework, just a framework, in order to make things safer.
By the way, Rails is on BugCrowd for anyone that wanted to know.
That wants to have bugs.
So I'm trying to think of what else is on here. Like I'm trying to look at what else is on BugCrowd that's a framework.
I don't know about BugCrowd so much, but I know like Augur is on HackerOne. Some of the Apache projects are out on those as well. So Augur is a blockchain market space. So it's a little bit it's like a market, but it's also a little bit of a framework. It's weird. And then in the blockchain space, you'll see like the Ethereum Foundation does its own bugs, and the Tezos Foundation does its own sort of like bug bounties and whatnot. So,
are you spending a decent amount of time on blockchain related stuff now?
Yeah, I'd say probably a good 75% of my projects right now are blockchain related, Hyperledger related things. Um, Lots of like fintech, lots of government NGOs coming up online with it. So, uh,
What are common issues with blockchain? Like, I mean,
everything.
what is everything? I mean, literally like OWASP top 10 or, plus everything else or
So we work on a project called Not So Smart Contracts, so where we try to collect those sorts of common blockchain, especially in the Ethereum space, sort of issues. And Ethereum has a foundation that we're part of, or a subgroup we're part of, called AppSec, which is kind of analogous to OWASP, trying to put together those sorts of things. Like, what are the top 10 issues that you see? Um, a lot of the time, what we see are very low-level issues. So time of check, time of use, reentrancy style issues. We see people having kind of like MFLAC, like missing function level access control. We see those sorts of missing access control things. But then we also see stuff like integer overflow or integer underflow, and those sorts of like machine level issues. So blockchain introduces things that you would normally see in the C++ embedded space, and it gives that to people who only understand JavaScript previously, and it does that with an entirely shitty, horrible language, and then is really, really wondering why you have all of these issues continuously. It's like dumping gasoline into a dumpster fire and then wondering why the entire fire like explodes out of control. Like they're not trying to make it safe just yet. There are some efforts like Viper to make it safer, but it's not there yet.
what language are we talking about here? I mean, you mentioned client, like people who wrote JavaScript previously.
So Solidity is the main programming language for Ethereum, and Solidity is JavaScript-like. It has all of the downsides of JavaScript combined with all of the downsides of C and none of the upsides of either.
Well, you sold me.
So
Wow.
it's an interesting. It's fun because it's like I get to work with compilers. Like I work with grammars and compilers and stuff like that. The Trailbits team brings a lot of really interesting tools. I get to think about stuff in a very different way. But unfortunately, the environment that we're trying to make better is just a very terrible one. Ethereum is an interesting idea, and it's just language-wise, it's so painful. It's so painful.
So it's fairly common for you to basically come across all these issues mentioned in the not so smart contracts. We got bad randomness, denial of service. I don't know what contracts can be forced to receive Ether.
So
Okay.
basically, in blockchain, you can say like, hey, Seth has a DApp. I hate that word, but he has a DApp. He has a distributed application, and Seth didn't code his smart contract to accept money, right? So what does the application actually do when I send it money? Like some applications fail horribly when you send them money.
Isn't that what it's designed to do?
Well, yes, like the language is designed that way, but you can still screw that up. Like again, the language has not made it safe. There are safer languages like Obsidian that try to make these sort of common patterns and transactions safer, but that's just not what's happening in general. Solidity does not make things safer. And we need fuzzing, we need that sort of testing there, because people are just not they're not figuring out the tests that they have, they're not figuring out the edge cases they have, and they're not figuring out the protocols that they have.
So it kind of sounds like there's a surprising amount of people doing development in Solidity for smart contracts. Is this primarily, is this like a random bunch of like some startups trying to do their own like whatever, version of Fiserv, or is it like mainly large financial service companies, or like is it, I mean, are you seeing a mix or?
It's a pretty good mix, 50-50 established companies or established agencies trying to get in, and as well as like startups, really, really interesting fintech startups that have interesting and novel ideas on how to like securitize things and whatnot. So it's interesting.
Yeah, I mean that's my like maybe it's just because I'm an idiot when it comes to blockchain. Seriously, like I don't know a whole lot, but I mean I don't understand the. I wouldn't say I don't understand. I haven't really looked into like what's the primary driver to move to the blockchain from, from whatever traditional. I guess it's leaving from what little I know about smart contracts. It's supposed to be a safe way of exchanging money and records and keeping and record keeping, but like what's the advantage for a financial services company to do that over their pre-existing sort of setup?
So the big thing for financial services, fintech, government, things like that is counterparty risk. So let's say Seth and I want to establish a contract, right? And we have a whole bunch of people that we need to prove that this contract was executed and signed, and Seth received the money that I said he was going to receive. It's really great for that sort of system. So if you want to show to the entire world that a set of transactions was cryptographically signed and approved by a consensus of your peers, it's great for that sort of stuff. So money, sending, they're called ERC 721s, non-fungible tokens. So these are like houses and things like this in the future. Right now, it's usually like, rare pepes and things like this. But,
right.
But basically, it's for transferring value, for transferring something around. I am not sure. There are people who are trying to make blockchains into completely general purpose computers. I'm super leery of that. I think there's all sorts of problems with it. But people will try, of course.
So is this one of those situations where, like, let's say I don't know, like for whatever reason, all of the records get burned down, right? Like all records for Capital One or Wells Fargo, they just, for whatever reason, like all records are lost. Is this a situation where, basically these contracts are a way for everyone to sort of, we don't need that Wells Fargo's records. This is a record we can, sort of everybody can access and see, and the transactions aren't lost, and we can have some assurance that it's legitimate, the things that we're seeing.
Yes, exactly. And that I haven't done anything to tamper with them, because it's like Git, right?
Right.
If I present you with a Git hash and you calculate through the tree, you can see it's a Merkle tree, right? You can walk through and see those hashes go through, or it's a directed acyclical graph, but still same idea. Basically, you can walk through the tree, hash everything at those values, and come to the same conclusion. I have the same Git repo that you do. And so what blockchains attempt to do is just distribute that process to everyone. Now, there's different types of blockchains. There's different sorts of ways of coming to consensus, and they have different use cases. I do think people are I think blockchain is hot right now. It's kind of like Web 2.0. Like, not everyone needs a Web 2.0. I mean, I'm old, so clearly Web 2.0 is not a thing, not something we talk about anymore. But as everyone on this call remembers, Web 2.0 for a while was like everyone was talking about it. It was like, but what are electrolytes? Like, do you even know?
We need more Ajax.
So
makes sense.
I think a lot of people are trying to get into the space and just aren't there yet. Like they're not really prepared for it. So, or they're not really sure why they're going in, but they can get investment capital. They can work on those sorts of things, and it's an interesting space, and I'd like to see more development there. I think it can become something useful, like the web. It's just it's in its infancy right now. It's embryonic.
Yeah, I think because we all hear the jokes about where everybody's kind of shitting on blockchain and machine learning or whatever. But that having been said, I feel like there are valid use cases where it would work, but that I'm not well enough versed and lack the imagination to see all of the really possibly very cool applications and where it would fit in. And so that's why I'm asking you all these questions, because I'm wondering, Maybe I'm the only one who's confused on what what all it actually brings to the table, but I'm sure that there are things that it does bring to the table. It can be helpful.
Yeah, it's good for distributed transactions that you want to have everyone be able to see. That can be service-based companies. We deal with folks who are do trading on the chain, so they actually resolve orders on chain via smart contracts, and it works. It eliminates counterparty risk. I don't have to trust Seth. Seth doesn't have to trust me. I don't have to say, oh, I'll send you the money. Oh, but it's going to get there. Don't worry, it's fine. Seth can literally see I sent the money, and then Seth can place his order, and we can have a smart contract that ensures those two things happen. And if it doesn't, I get my money back, and Seth gets his money back. So,
Right. So from like a PayPal, Venmo type situation, it's pretty useful in that kind of. Although what you're talking about is not even making the final purchase until not completing the contract until something else has been seen, like for instance that first transfer of money.
Mm-hmm. Absolutely. Yeah, it's good for escrow. It's good for multi-signature validation. So if Seth and I own a company and we want to pay you, we could have a contract that said Seth and Stefan have to agree to this, and it holds our money until Seth and Stefan both agree to this. So it's useful for that sort of thing.
Nice. Yeah, I could see that being useful. I could, like, for instance, I mean, we just did training for OWASP, and we had to do our little. So because Seth and I have different LLCs, right, and we obviously get paid for the training, we have to submit individual W-9s to them, and then. Like there's a bit of back and forth, on this or that, costs, etc., how many students attended. Yeah. And so in a situation like that, I could definitely see that being pretty, it being useful, right?
Yeah.
Like if basically for every student that says like for every student that pays, right? Like it's a simplified situation for us where we say like, oh, okay, well I'm just using this as an example because it's something that I can apply this practically to.
Of course.
Yeah. And then like we based off those students and like everybody said, yay, we paid and whatever. And then Seth and I can easily agree to take X amount, 50-50, and we can show that and OWASP could show that that's been distributed and all that stuff. So in that kind of situation, but again, I don't know how that, well, I could see how that, because there are services that somewhat do some of this, right? Like it's just not cryptographically, well, I don't know, like it's proprietary, right? It's whatever their system they're using. So
claim it's cryptographically secure.
Yeah. But probably not. Yeah. So
yeah, it's useful for that sort of thing, that sort of counterparty risk and that sort of like escrow services and multi-signature authentication. You could even in your class like example, you could have the students pay and you could see that they cryptographically paid and then only give students grades who had paid. Like there's no reason why you couldn't do that. You can codify all that sort of stuff.
But again, you could sort of make the argument that all of this can and has been done just without the cryptographically secure part of it, I guess.
Well, cryptographically secure you can do. What you can't do is counterparty risk unless you have a wider consensus there.
Oh, I see what you mean. So that we all agree that this happened, basically. That's
right. I can in a single system, I can say that Seth signed every one of these transactions. What I can't say is that those are the transactions I expected to be there because Seth has the power to sign them no matter what.
So like, okay. So there's repudiation there. There's like saying, okay, all right, now I totally see. Okay, cool. Thanks for explaining the blockchain on Absolute AppSec. No,
So
I mean, honestly,
we'll tag the episode. Stefan explains blockchain.
No, but I mean, bringing it back to testing though, we do see a lot of blockchain folks have backgrounds in like traditional JavaScript testing, and they bring truffle tests and they sometimes even bring echidna properties to us. And then one of the things we will do is talk about what the intentions there are and see if there's any edge cases that we can find either through symbolic execution or through fuzzing to actually expand on those test cases and why those are actual findings. So it's cool. It's really neat to be able to work with developers and try to not only say, here's a bunch of like terrible problems that we found, but we can also say, here's a bunch of tests that we show that when you fix these tests, this code that we're handing you will not break anymore. So that's what's fun.
It seems like an interesting thing to just because, honestly, for one, the fact that it's new, and two, the fact that because it's new and because it's, newish, that you're kind of building in, you are making up your own sort of OWASP top 10, if you want to call it that. That's got to be fun. Like, are you guys, so you're keeping, I assume you're keeping track of like, or whoever all is all involved, maybe it's multiple companies, keeping track of metrics on each one of these things that you're finding and sort of creating empirical data.
We haven't got to that point yet. We're talking about ways of, so the neat thing about the Ethereum community is that you can just describe these sorts of things. There's our ERCs and EIPs, right? So an ERC is kind of similar to an RFC. You basically, state you want to do these sorts of things. You have this idea. Whereas an EIP is the actual implementation thereof. So there is an ERC right now for creating something similar to the OWASP top 10. Trail of Bits has some feedback on it. It was created by another company called Consensus. But we're working within the community to try to come up with something live on GitHub with to actually come up with those sorts of issues. And that's why not so smart contracts are out there. That's why like Echidna is out there and that sort of stuff. It's just there. It makes sense to put it out there and let other people use it. So.
Nice. I'm looking up some of the things you mentioned. That's why I'm kind of quiet here.
No, it's no worries.
You didn't have any questions on the blockchain? Just me?
What's the blockchain? Is that cyber related? Is that no?
I don't know. Did you have any experience with that, Seth? Or have you been exposed to that?
Not necessarily. No, not really.
I'm gonna pull you.
I think yeah, exactly. Like every time, like we have discussions on it, and I keep looking into it. Right, like I understand probably more how Bitcoin or something like that works, but the smart contract stuff is definitely interesting as far as where it's going and how that's being developed. I think there's going to be more and more of that actually pops up, especially in the FinServ space, like you're saying. I think that's where it reduces that risk. People are going to go that direction. But I also feel like there's a whole ton of startups that are out there that are trying to force a technology and a name onto an industry that doesn't make any sense.
Yeah, for sure.
Yeah, I don't understand. Like, who's that? Does that sell better just to put that name in there? Like, I can't imagine that. I'm curious, like, what that does for your marketing. Does it make it more likely to be a product that's purchased?
Now it's blockchain, right?
Yeah, like how much does that actually help?
Well, did you ever see the Long Island blockchain company?
No.
I think it was Long Island Iced Tea Company. They changed their name to like the Long Island Blockchain Company, and their stock shot. They have no investment in blockchain whatsoever. They're not creating a blockchain. They're not using the blockchain. They just literally renamed themselves, and their stock just shot up through the roof. I think there's a little bit of irrational exuberance right now for it. But for those players who are in the space and actually working on Ethereum, it could be Tezos, Ethereum, that we work with some alternative blockchains. I'm actually working with clients right now who are creating a blockchain. Those sorts of things can make sense. It's just, there are definitely people who are trying to force problems, like Seth said, into this space. And there are venture capitalists who are throwing money at them to do so.
Yeah, I could see VCs doing that, right? Not that VCs are like, oh, stupid VCs. No, they're not. It's not like that. But there certainly are VCs that are like dishing out smaller amounts just for stuff that sounds viable.
Yeah.
Like
Angel investments and Series A and whatnot, like just like, oh, that sounds neat. Like I'd love to have a blockchain portfolio. But we actually have clients who come to us who help us, who ask us to help them understand if an investment is worth it for them.
oh,
We do all sorts of like interesting asset custody cases and things like that. So like if a client is holding like crypto assets, like is the way that they're holding these cryptocurrencies actually secure? So we work in related spaces. Yeah, it's fun. There's a lot of very interesting things that go on there. So
Yeah, I didn't realize that about the long blockchain company. I guess that's the name of it now. That's hilarious.
I posted a link, by the way, to that Stefan, and I'm assuming that's probably what Seth's reading. But yeah,
I was looking at there's a Wikipedia article.
is there?
It. Yeah, and it talks about how they were going to be delisted by the NASDAQ because of it.
yeah,
Crazy. Yeah, well, and that's just it, right? Like, I'm sure they got like a huge bump, and so it almost looks like insider trading, or you know what I mean? That's just like this crazy. I don't know. Yeah, it does go back to the Web 2.0 days. It really does. At that point, it made more sense probably for most companies to be jumping on the internet bandwagon and all of that, but blockchain just doesn't. There's some problems that it solves well. Right? And even smart contracts, but there's other problems where it makes absolutely no sense, and yet throwing it into whatever gets you more money from the investors. So why not try? I guess.
They actually have a website still, and it's got like crappy stock photos. It's got the lock with the crypto, random numbers, looking crypto. Oh my god, what a piece of work this is.
Yeah, it's pretty funny to see that they just literally tagged like blockchain into their name, and all of a sudden they were like, everyone wanted a piece of it. It was a hot stock, even though it was literally just iced tea.
They've got their corporate governance, and the images for the people that they list are just all broken. It won't even render.
Yeah, of course.
Failed to load resource, not accessible. Yeah, that is hilarious.
I think the way that Ethereum says to think about smart contracts is if you want to have a global computer verify your calculation, and it's on something that can run on a cell phone from 1999, it's an appropriate application for Ethereum. There are alternative blockchains which speed things up. There are things like EOS, which are trying to make completely general purpose computers. Joanna Rukowska actually just left Invisible Things. She's no longer working on cubes, and she switched to Golem, which is a distributed blockchain computer system. So, I mean, people are like moving out of pure security, like cubes, to going over to work on blockchain stuff in a similar space, but obviously they're working on something related there. So,
wow.
Yeah, Joanna Rukowska just left information security to go be the chief security officer over at Golem.
I'm looking that up. Yeah, interesting.
Yeah, it feels. I mean, Ken and I were traveling for a few weeks, and it feels like we're kind of out of the loop on some stuff, right? We've been teaching people how to perform code reviews, and that doesn't necessarily jive with sticking on Twitter and everything. Oh yeah.
Anyway. It was a fun couple weeks. Or was it more than that? I don't know. I was gone out of the country for 2 weeks, and then we did AppSec. How long ago was AppSec used? Was that 3 weeks ago or 3.5?
Yeah,
I can't remember.
3.5 or something like that.
Yeah. So it was almost a month ago. And then we turned around and went to Australia, and jet lag and all of that. And then Ken decided to take a vacation.
I know. How dare I?
Yeah.
What a jerk.
Yeah, exactly. Posting pictures while the rest of us have to work.
I know. I was in Hobbiton with the Hobbits in New Zealand. That was fun.
I hear there's a new blockchain company down there.
There probably is Lord of the Blockchain or something. I don't know.
Lord of the Blockchain. I'm stealing that. Not there.
It's out of New Zealand. Yeah, we had a good time. I think it was really rewarding. Like I guess we can talk about. I think we're getting to the end of the show. So, and Stefan, I know we're going to have you back on November 20th, so that we can basically talk more about like your origin story, because we've never gotten to talk to
my origin story.
Yeah, we've never talked about it.
Like,
You're bit by a spider. That's what you. That was your
exactly.
origin story?
Yeah,
Awesome. Your parents weren't like killed outside of a theater, and then like
they
you were afraid of bats and stuff.
No, they eat themselves to death. I mean, spiders tend to do that, so it wasn't really tragic. It was just natural, you know. So.
That sounds like a Stefan response. Sure does.
I had to think about that.
I knew we were going to have you back on, and thanks, by the way, for jumping in tonight.
Of course.
But I know we're going to have you back on November 20th, so we can pick your brain even more. Yeah, since we're coming to the end, I mean, I guess the only thing to mention about the course is it was pretty fun, because like by the second day, in AppSec Day Melbourne, my favorite part of this was that we had everybody apply what they had learned for the second half of the second day. And dude, we walked away with people who actually found issues inside of like open source applications, because we had them download over. We gave them a list of like some cultivated, like here's some apps that might be right to do a review on, and they paired up like 2 people together. And so we had them follow our methodology, not necessarily so that they could find vulnerabilities, but so that they could get. The whole course is about practice. We speak for like 30 minutes, 40 minutes, then they practice whatever we just showed. And each exercise builds upon itself. Anyways, the point being that at the end of the second half of the day, these people came up, and the students had not only like done an excellent job of basically breaking down what, everything about the application, from its business purpose to its technology stack, to brainstorming security weaknesses to go back and look at, and creating a checklist, to like actually having found vulnerabilities. Multiple groups found vulnerabilities. It was amazing. It was a fun time. Like, what was your favorite part, Seth?
Yeah, I mean, definitely seeing them put it into practice kind of re-energized me, as far as like, oh, this is, I know it's always worked for me, the process of how we distill an application and other things, but it's interesting to see others actually do the same thing. It also takes me back to almost what we were talking about earlier about exploits and flaws. Is I feel like we put so much emphasis in the security community on, hey, what's the latest cool exploit? What's the latest cool technology? Whereas that's not the process that really any of us use on a daily basis to actually distill an application, to perform some sort of assessment, to actually fuzz. It takes so much more effort than just, hey, I did X, Y, and Z, found X, Y, and Z, and followed this through, and all of a sudden, hey, I had SQL injection, or I was able to transfer myself money, or whatever it is. We gloss over the time and the actual process that we use to do any of this, and it's almost a detriment to people getting into the field, because they feel like, hey, if I can't do this within the first 2 hours of looking at an application, I'm done. I'm not an expert, right?
Yeah, I mean, Stefan, that was the interesting part, was that we created this sort of like, we're still refining, and we will continue to refine, but I mean, honestly, we've got Seth and I had our own processes, which were very similar for doing code reviews, and I'm sure you have your own process. But what it's weird, because we're taking that that experience, and we're sort of like, this isn't to pitch the course, this is to talk about like just the fact that like I haven't found a great set of like instructions out there for, here's how you perform repeatable code reviews. Here's your process. Like, here's a framework for doing that. And so we're sort of like creating that, you know what I mean? Like we did create that, and we are handing that out to people. And it's sort of an exciting thing, just because, like I said, we don't come across, I mean, have you guys really come across any, I had to learn this stuff through trial and error. I mean, I don't know that anyone was actually teaching, here's how to do web app, mobile app. Well, what we're focusing on web app, but web app code reviews. Like, how did you learn, Stefan?
I mean, I was a developer previously, so I've read a lot more code, and I don't think people appreciate how much code developers have to read. Like in security, like Seth said, we constantly focus on like the cool whiz bang thing, whereas like most of the time it's just ass and seat reading code.
Yeah. Yeah, and that's totally it, right? It's not. It doesn't. Yeah, there's kind of flashes of inspiration when you're looking through that code, but most of it is how much time have I put in to this application, right? How much time have I taken to understand what's going on, what the different functions are that I should be looking at, and identifying those edge cases or whatever it is that could lead to an exploit. It takes. I mean, it takes a lot more just kind of dedication and following the process than it does. Hey, I know that this is a vulnerable function from this API because of X, Y, and Z.
Mm-hmm.
I mean, some of that you get from experience, definitely as a developer. But we've always said that kind of the best AppSec professionals are ex-developers, right? Or it's easier to come up as a application security person if you've done development in the past.
Well, I also think your point, Seth, about folks having like pen testing being just terrible QA testing. I do think QA testers have really great backgrounds that they can just bring to bear if they just understand the architectural controls and the flows. They're awesome security resources.
Yeah.
That's interesting. Did you have problems with people reading code versus writing code? Like
In the course
they get
itself?
in, they can like write stuff really quickly because they're using like IntelliSense or something like that, but they're not used to reading code ever.
Oh, we actually had mostly. So we in the second course, it was interesting. The first course was mostly security people, and the second course was mostly developers. And I would say that the developer. I mean, both groups did great. The developers did surprisingly well, and I say surprisingly well, just because my kind of thought there was that it was going to be, if you come from a security background already, but I think it comes down to like what you said, they are used to reading code. But again, it's also like, we were looking at the overall overarching methodology. So yeah, there's definitely a skill in finding vulnerabilities. But, one of the things we talked a lot about was it's honestly more about being organized and meticulous and following a process than it is like, being the person that picks up, because you'll see this. How many times have you seen people who they dig into code and in the first day they find a couple vulnerabilities because they're just pinpointing these are the things I'm looking for. They've got their like, but then there are things they look for, but then after like 2-3 days they have nothing else. That was like, that's what they got, whatever they found in that first day. And the reason is because they're not being comprehensive, they're not following a process. And so if somebody that's continually going at it at a paced level for 5 or 10 business days or whatever they're allotted, or even 3 days, whatever the case is, will come away with more findings than that person who just was like, oh, I'm searching for SQL injection, or I'm searching for whatever the business flaw, and not following a process. So anyways, that was surprising though, I'll say, and it's probably what you said. The developers could read code really, really well.
Mm-hmm.
So
just arming them with what to do is interesting.
Yeah, and I think that was the main feedback that we had from those developers, is they were like, well, what is it that we're trying to look for? How does this differ from a traditional code review, where they dive in and for an hour they're only looking at 200 lines of code, right, at a max, which is that feels like such a luxury to any of us, right? As only 200 lines of code in an hour. You know how much code I have to comb through and actually be able to read and distill quickly. That's like, that would be great, but no one's going to pay us to do that from a consulting perspective or even an internal perspective, right? Unless you work for MicroHub over there, whatever it is now.
Yeah,
Well,
I had to throw it in.
At Trail of Bits, we get some pretty long-term assessments. I just got off one that was 18 person weeks.
Wow.
Oh wow, that's unheard
Yeah.
of.
Yeah, it was amazing. It's one of the things that we partner with clients to do, is to get these really longer term assessments so that we can actually go come away with actual understanding of code. So I admit it's been a luxury, and it's been really pleasant, and it was totally a culture shock and shift for me when I went to Trail of Bits, because I was like, holy crap, first week I gotta like knock all of these findings out, and then it was like, oh wait, we have many more weeks to actually understand what's going on here, and I can really dive into things. So it's nice. I like it from that perspective.
So you weren't triple billable with 1 or 2 weeks to get your all your assessments done here?
Nope, and no one made claims about me as a person either, so it was perfect.
Amazing. That's amazing.
That's awesome.
My CEO thanks me when things go well. It's pretty nice. I'm pretty happy with it.
That sounds like quite
like
a
a
good setup.
Yeah. Dan is actually nice when you do things. It's pretty impressive.
That's awesome. Well,
Sweet. Anyway,
as opposed to no. All right, we'll end it
as
there.
opposed to you, Ken, you big meanie.
No,
Yeah,
he's not
No, but
talking
I mean,
about me. But
It's really nice.
there's a grind across the industry, right? It's all about how many apps can we turn out as quickly as possible from a lot of the consultancies, and I'm even looking at like the big five, right? Like the big accounting firms that have a security division now. You see them come in. I've got a couple of clients that I see them come in, and their security, their code reviewers only have 2 days to actually analyze an application, 2 or 3 days, and that's it. That's all they get.
Mm-hmm.
There's only so much that you can understand in that long, right? I mean, even if you have the process down, there's only so much that you're going to find. Sweet.
You mean you can't read 100,000 lines of Java code in 2 days and have meaningful findings out of it?
I might be able to find some SQL injection, do some regex searches, right? That's just it, right? They throw a static code analyzer at it. They review those findings. That's 1 day right there at least. And then the second day is poking around and then call it good. So anyway, I mean, that's kind of soapboxy, but it's definitely it's definitely an issue, right? It really comes down to what the client wants. Is it a checkbox? Is it compliance? Is it actual security? And I almost feel like we've got to cultivate more of those clients as as consultants, as people in the industry that share that understanding that it's not just a quick fix. It's just not compliance that we're looking for. We actually want to fix their applications and make sure that they are secure. Anyway, Ken, what was there anything else from the conferences that you wanted to mention before we call it for today?
not. I think some of the other things I want to talk about are gonna eat up a lot of time. So maybe for the next episode. Actually,
I'm sorry, Ken.
No, not at all. No, I'm glad you jumped on. Honestly, I really appreciate that. I'm the one who
Way
asked.
to go, waste our nights.
Yeah, I asked Stefan to come on. So if anything, I'm happy. But excuse me. But dang, next week we've got Travis McPeak from Netflix. Mike McCabe, Stefan, Mike.
I do.
Mike's gonna join us on the 13th. This guy named Stefan Edwards on the 20th.
Nice.
I don't know who he is. Yeah, sounds crazy. November 27th, Matt Conda. We got a few others, Sean Porras, and Keith Hoodlet, all coming on. So we've got a good lineup of guests. I know I had created a little short update video where I mentioned we have a lot of good guests. We have a lot of good guests coming, minus Stefan. No. Thanks again, Stefan. No, I'll make sure to bring my Googling fingers for your November 20th episode. But so we've got a good lineup, and I don't think there's anything else to mention. Well, I guess we can say it. I think it's going to be officially announced soon, so we can just say it. Our training course got picked up for AppSec Cali, so we will be going to AppSec Cali this year.
Nice.
Yeah.
That's
So
awesome.
I'm excited because I missed last con. Like last con and AppSec Cali are my two, are a couple of my faves, and just haven't gotten to them the last couple of years. So
Yeah. Joe Rosner, who is out in LA, he's been asking me to go to AppSec Cali for a while now. So that'd be fun. Maybe I'll go out there and meet up with you. And
you totally should. You totally should. I'm gonna bring my wife out too. So it should be cool. Like, gonna turn into a fun week in Santa Monica. So
that'd be really
definitely
fun.
go out there.
I'm writing that down.
Yeah, write it down. Pen and paper, huh? You're still working on the notepads?
I do. I have a blockchain of notes.
It's all one note after another. You
Exactly.
sign them if you go on, so you make
Exactly.
sure that
It's called linked timestamping. That is actually a thing for newspapers. Linked timestamps.
There you go. Keeping it lo-fi.
That's me.
All right,
Cool.
guys. Well, thanks for joining us tonight, Stefan.
Anytime.
Always entertaining. I'm sure we'll talk more about the other things on November 20th, and we'll try and get a calendar up with actually upcoming guests on the website. Find us there if you're listening, or join our Slack channel. Hit us up on Twitter, whatever. I mean, we're all around, and we all love to talk about this stuff. So, thanks again.
Thanks everyone. Thanks, Stefan.
Thank you, gentlemen.
All right.
Bye-bye.